Hi, everyone. Thank you for joining us for today's session, Azure OpenAI Landing Zone Blueprint. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we do ask that you please be mindful of your commentary, remain professional, and on topic. This session was recorded. It will be available to view on demand. However, there will be time at the end of our presentation for a live question and answer session. I'm now going to turn it over to our presenters, Asaf and Hamat, for introductions. Thank you so much for both of you joining us today.
Hi, everyone. Hi, Amint.
Hi, Asif. Thank you for joining, everyone. We're going to be presenting today a blueprint for OpenAI. And with that, can we have the slides, please?
Sure.
Okay. So today's agenda is going to be around overview of an introduction to a company, To Be Cloud. We're going to go through the Azure Cloud Adoption Framework and what are the key design principles that make a secure cloud landing zone. Upon reviewing that information, we'll go through introduction of an Azure OpenAI services and a reference architecture associated with that. After that, Asi is going to go to an actual live demo of OpenAI landing zone as well as OpenAI service that'll help you basically do not just learn the theory, but the practical aspect of OpenAI as well. After that, we'll go through a summary and a Q&A session. Next slide, please. So briefly about me, my name is Hemant Chaveri. I'm the Global Head of Solution Architecture for To Be Cloud. I'm proud to be with the company, and we are looking forward to working on the Microsoft side. Next slide, please. So who we are a next generation of Azure MSP partner. We have roughly 350 digital native partners. We support them in various ways. We support them through cloud optimization. We support them through unlimited consulting and 24/7 technical support as well. We are an MSP partner, but we have, as compared to any other partner, we are Azure expert partner. And we have competency in data, AI, digital app innovation, and infrastructure. We have security certification as well in ISO 27001. And with that, we have experts who can give you technical guidance. Next one. So what is the Azure Cloud Adoption Framework, and what is the life cycle of it? So Azure Cloud Adoption Framework is basically a framework that allows you to create a landing zone and migration or innovation with the best practices in Azure. So it starts out with defining a strategy. And with the strategy, we basically want to define what is the outcome you want to achieve. This is probably the most important thing you want to define for any organization. With the next stage of that is planning. Once you've defined the outcome that you want to achieve, how would you want to achieve that outcome is the planning stage of it. This is a series of steps that allows you to basically establish a cloud center of excellence. The planning, how are you going to support it once you have a implemented cloud landing zone. With the ready phase, you're basically ensuring that you have a cloud landing zone that you can operate yourself, or you can have an MSP like To Be Cloud to operate that. And once you have achieved a cloud landing zone, then you migrate your workload. And there are various ways you can migrate your workload. One, via lift and shift, you can modernize your workload, or you can actually innovate using new architecture into the cloud landing zone. The most important thing when you do the cloud adoption framework is that you want to ensure that your security posture allows you to be putting all the security controls and to have your cloud landing zone to be very secure. Once you have done all that, the most important heavy task is to manage it. You want to be cloud is a partner you can count upon to manage your infrastructure as well into the cloud, and put in proper governance procedures in a way that allows you to basically organize your resources and govern them. Next slide, please. So, what are the design principles of a secure Azure cloud landing zone? It basically starts out with a platform automation and a DevOps. We use infrastructure as code to create a secure cloud landing zone. All that infrastructure code basically allows you to do the Azure billing and Active Directory tenancy. We do the resource organization, appropriate tagging of the resources. We put in the identity and access management to assure that all the resources that you're accessing is for the people who are allowed to access. The last part is the network topology and connectivity. This ensures that all the networking that needs to be in place to access your application or workloads within a cloud landing zone are reliable. So the three pillars are the management, security, and the governance. These are the key important principles that need to be followed to have a secure cloud landing zone. Next slide, please. So with that, I will hand it off to Asif to basically walk you through the next steps and the demo.
Thank you, Hemant. Hi, everyone. Welcome to the session. My name is Asaf Leibovich. I'm the team lead solution architecture here at 2B Cloud. And in the coming slides, we'll discuss about the main components and the concepts of the landing zone and implementation of the OpenAI service as part of the landing zone. So we'll start with the Azure OpenAI service. So this is based on a collaboration of Microsoft and OpenAI, where we get the ability to host, deploy, develop, and maintain OpenAI foundation models and use them as part of our applications. What we basically get is eventually an API endpoint we can use for making calls to the models and get responses from them. The models we can use as part of this service are GPT for natural language understanding and generation, DALL-E for image generation, and Whisper for transcribing and translating speech to text. The Azure OpenAI service provides business and developers with high-performance AI models at production scale, and it is used by Microsoft to power GitHub Copilot, Power BI, and Microsoft Designer. Next thing will be the landing zone. What you can see here is the landing zone reference architecture. The landing zone provides us with a solid foundation for our cloud environment. It helps us manage resources that ensure governance, compliance, and security. This implementation uses all the design areas presented earlier, where it's used by us for a basic starting point where we can design and plan our environment to use in accordance to specific use cases. This specific diagram shows a full usage of all the available possibilities, and it gives us a good baseline to start and progress with our planning to utilize the cloud in the most efficient manner as possible. The landing zone is independent of application architecture. It's constructed of services that will be used as infrastructure for our deployed applications. And this is a good starting point and a reference that we will look into with additional use cases. The next landing zone is a specific use case that we'll cover here in the session, which is the landing zone for an Azure OpenAI service. In this use case, we want to host our OpenAI service and use it as a backend for our own workloads, our internal application that will access the API and provide the services based on the OpenAI services. This landing zone focuses on several design areas that we saw earlier in the basic landing zone and in the conceptual architecture, where we'll use the connectivity and the network traffic and the security. This is the main focus that we will use as our landing zone architecture and planned environment. The OpenAI service is a managed service that will enable us to deploy and use the OpenAI technology such as the DPD, and it is integrated with the Azure Machine Learning, allowing us to build, train, and deploy AI models with the scalability, security, and efficiency of Azure. We'll now move to a live demo of an environment that will be created as part to represent the OpenAI landing zone reference architecture. I will switch to a screen. Okay, so here we are connected to an Azure environment where this environment is already, it was created automatically using an execution of an infrastructure as a code, an environment, a Terraform project that eventually creates, installs, and configures all services to behave in the way that the architecture design was visualizing. And in this demo, we will review the main services representing the main concepts of this architecture, and we'll also have some live demo to showcase the abilities and the main factors that this architecture wants to achieve. So we'll start with an overview of the subscriptions. The landing zone provides usually a different set of subscriptions to represent different type of design areas, where in our case, we wanted to utilize the connectivity and the application workload concepts. The first subscription will be used as our connectivity subscription. We'll use it to connect to an environment that privately hosts all the services that will be used by our application, whether it's the OpenAI service or the services that are behaving as the proxies and the gateways to use the service. The other subscription will be used as the workload subscription, where all the services that eventually host our applications, including OpenAI service, will be located. The next service we would like to look at is the OpenAI service itself. Again, this service was created as part of the Terraform execution, and it is already available with configured settings that allow it to be privately hosted and accessible only from private connectivity from within the environment. First thing we would like to see about this service is the service key, which eventually is used as a parameter to authorize a request made to this service. This key is eventually, when we will use it, it will be encapsulated and stored only from a single point that will access the OpenAI service. And it will not be exposable to the rest of the applications or the rest of the components in our application, making it tightly coupled to the OpenAI part and inaccessible for other resources that might not be safe to use. This the encapsulation concept is taken care of here in the place that we will handle this key. Another thing which is important is the endpoint. Right now we cannot see it, but eventually we have an endpoint where we will try to send all the requests to access this DNS address. And one more thing that's important here from security aspect is the network accessibility definition of the service. What we can see here at the networking tab, we are able to see that the OpenAI service is currently applicable, and it's available to use only from specific virtual network, from specific subnet inside this network. And if we still want to have some connectivity from some public IP addresses, whether it will be our office IP address or some IP address of some external service that we would still like to be able to communicate with the service itself, we can define firewall rules to enable public connectivity, but only from specific whitelisted IP addresses. Next service we would like to see here will be the virtual networks, representing all the connectivity and the traffic flow between all the networks. So we have an architecture of a hub and spoke networking. There will be a hub network and the connectivity subscription where we will connect from the public internet into a Jumpbox server that is only privately defined in the hub virtual network. And this network is connected with the spoke network And in our use case, this spoke network will host all the services related to our application workload. If you look at the hub network, we'll be able to see that it's connected using virtual network peering with the spoke network. The same will apply to the spoke network for connection with the hub. Additional thing here that we would like to see is the definition of the subnet and their contents. We'll have a subnet hosting our Bastion subnet. The Bastion is the service that will eventually enable us to connect remotely to the Jambox server and from within the remote desktop perform the rest of the connectivity and the required tasks from within the virtual network. We have an Azure firewall subnet. The landing zone architecture also deploys a firewall which controls the traffic going outbound from the environment to the internet, making sure that we will not reach any unwanted target IP addresses out there in the internet. If we look now at the spoke virtual network, we'll be able to see that again, it's connected with the hub network. There is a peering from both sides that enables the connectivity between the networks. And from the subnet's point of view, we'll be able to see that there are several subnets here to host several types of services that are the workloads of our application. We will host an API management service. This API management will be used as a gateway, as a proxy to connect to the OpenAI. It will serve as the front end of the OpenAI, and the OpenAI will be serving as the backend pool of this service. API management service will also allow us for gaining additional security feature, enforcing rate limits on the amount of requests down to the service, whitelist IP addresses to make sure that only allowed connections can be made, request and response management using policies to control headers or the content of the body of the request or the response. In addition, we'll have the subnet hosting a database. Our workload usually contains some sort of a database, so it will be hosted as part of the landing zone spoke network. The subnet of the AI hosting the OpenAI service, subnet for services, for general types of services. For example, we will host a key vault to store our secret values and passwords and sensitive data using general services inside this type of a subnet. We'll have a subnet for the web application. This subnet will host a demo web application that we will also see here in this demo that also accesses the OpenAI service and uses it from, again, from within the internal environment. And another subnet hosting an application gateway to be used in cases where we would like to expose our internal resources to external communication from the public internet. Application gateway can also come with a WAF, a web application firewall, to add additional layer of security to our workload and landing zone. Another thing that I would like us to see here is that each subnet comes with a routing table defined over it, which eventually takes control over the traffic that goes to the internet. Usually the address prefix of 000 means the traffic that goes to the internet, and all this traffic will go through the IP address of 10.100.04, which is the IP address of the firewall that we mentioned earlier from the hub VNet. So this is how we will implement the traffic that will go from the outbound, going outside from the internal environment to the internet through the firewall service. The next service I would like us to review is the API management service. So the API management is the service that controls the way that we expose our open API to client applications. The API management is also on its own hosted internally inside the virtual network. In here as well, we can go to the network plate and see that it's connected to the VNet AI LZ, the spoke network, with the SNet, the APIM subnet, which is one of the subnets in our spoke network. And it was also a subnet that was defined in the OpenAI service as one of the subnets with the ability to connect to the OpenAI service itself. All the communication is done on a private, from the private network of the Microsoft backbone. Nothing will be going through the public internet for communication in the internal environment between the various services. Next thing we would like to see about the API management service is the APIs themselves. We'll use an API endpoint that will consist of several policies that will construct the way that we communicate with the OpenAI service. The way that we control the traffic is done in a way that we will build on top of the request that will reach the API management service. We'll add several headers and details of the backend pool that will allow the communication from the API management to the OpenAI service. We can see that we will define a header setting the internal requests API key HTTP header to the access key that we saw earlier in the OpenAI service, and another header for making sure that the content is structured as a JSON content, which is required to invoke the OpenAI service, and we'll set the backend pool address. We'll make sure that the request that reaches the OpenAI service will eventually reach the backend URL, which is the OpenAI service URL. And in addition to, in order to communicate with OpenAI, the internal address will also include a query string, so we will add another query parameter to include this specific detail, so we'll be able to communicate with OpenAI service. So using a set of policies to define on top of our operation will allow us to encapsulate eventually the OpenAI backend from any calling application, allowing us for better security, better scalability. The calling application doesn't have to be aware of which OpenAI service it uses. We can implement several endpoints of OpenAI, configuring the header for each one of them, and then the calling application will just know that it needs to receive services from an OpenAI endpoint, and it doesn't matter which one is it, meaning OpenAI behind the scenes can scale, can change, and it will not affect the calling application, while encapsulating the sensitive detail of the API key that we will keep only in a single location and away from a possible client application that will impose additional management and overhead for maintaining our environment. The next service I would like us to review is the private DNS. Using a lot of private connectivity requires a definition of the separate DNS records inside our environment. What it means is that when we are connected to a specific virtual network, a private DNS zone service is enforced on a specific virtual network, and it allows for a DNS resolution for traffic inside this virtual network. What we can see here is that we are using a specific private DNS zone for an OpenAI service, and it uses an A record exposing the endpoint of our OpenAI service, which was configured earlier, we saw it earlier, and it represents the endpoint with an internal IP address, which is the internal representation of our OpenAI service. Everything again is deployed using the Terraform configured as an internal resource inside the virtual network. And in order to make sure that we do not access the resources publicly, we will use this type of service to make sure that the traffic goes and accesses the internal resource of the OpenAI or other various services in our environment. Next service I would like us to see is the app service. This service hosts a sample web application that contains some simple chat application that will connect to the OpenAI backend and allow us to perform some chat with it. This application is, again, it's another use case where we have some internal application that needs to communicate with the OpenAI. This application is configured to be only privately accessed. We can see in the web app networking tab that there is an access restriction definition defined on it. It doesn't allow public access connectivity to the web app. It means that we will only be able to access it, and we will see it soon live. We will not be able to access it from the public internet, only from within the virtual network. And the last service that I would like us to look at in this review of services is our Bastion host. This is eventually the managed service that will enable us to connect remotely to a desktop, to an RDP session inside the Jambox virtual machine that we have in, and allow for the secure connectivity and access to the internal environment. So let's go for the live demo, showcasing the way that the landing zone environment was created for us. I will start by a simple attempt to call the OpenAI service from my own PC. I will try to invoke a web request trying to access the OpenAI, asking some question, and let's see what I will get in response. As you can see, I will get a 403 HTTP response of forbidden, saying that there is some access denied policy based on firewall rules that denies my ability to access the service. So we can see that the service is not accessible from the public internet, and it can only be accessible from the internal network. Let's try to access it from the network. In order to do this, I will connect to a virtual machine that is hosted in our environment, our Jambox server. Connect via Bastion. In here, I'll get to a screen asking me to connect. I'll provide some username and password prepared in advance. And we are connected remotely to the virtual machine. And in here, we'll be able to perform some web request calling the API management to get some response from its backend, the OpenAI service. So we'll define several details in order to invoke this call. We'll set some HTTP headers to be used to communicate with the API management. We'll define the URL of the API management. As you can see, this is the DNS of the API management, which, as we saw earlier, there is a private DNS zone record inside the environment that maps this DNS to the internal IP address of the API management service that we have in our environment. We'll define the request body. As you can see, we'll define a simple question, and we'll try to send the same string to the API. Let's now invoke the web request. And let's see what is the response that we received. As you can see, we received 200 OK. This is the response that we received from the API management service. Okay, we were at the Jambox server, connected internally to the environment, to the hub network. The communication is done to a service that sits on the spoke network using VNet peering, and we received the 200 OK. The request went successfully, and there is another content in the response, which is another 200 OK. This is the response from the internal service, meaning from the API, from the OpenAI service that sits behind the API management. Let's see the details of the response. Let's look at $res.content. And we'll be able to see that we got some response from the OpenAI service, which was encapsulated behind the API management. So we didn't provide any API key or any specific identifier to the OpenAI service. All the communication was done with the API management with the front-end proxy that stands in front of the web service and allows us to encapsulate the details from the calling application. So this is one use case of using the API directly through an API management service. The API management provides us with several other security features and advantages that we would like to consider using as part of our architecture. The next scenario that we will look at is invoking the web app. We have a web application in our environment, the simple chat app, the demo app. Let's try to access it from the internet. This is the application URL. If we try to access it from our browser, we can see that it will not be accessible. We can see that we get 403 forbidden. There is some firewall blocking us. This was the access restriction that was defined earlier in the networking tab of the app service. Now, if we'll go back to the Jambox server and open a browser there and go to the URL, from here, we'll see that we have access. We have access. We'll be able to start a new chat, ask some question, our standard question, once upon a time, and we'll get some response from the OpenAI service. So this is it. This is the several scenarios and use cases that we wanted to showcase as part of the implementation of the landing zone reference architecture in our environment. Of course, all this environment that eventually was created automatically is based on a Terraform that is hosted in this GitHub repo. It's available, and the link to the repo will be shared, of course, at the end of the session. We can see that eventually what this repo does is host a Terraform project that eventually deploys this setup of an environment. We can just clone the repo, configure it according to our requirement, mostly set up the subscription ideas of the connectivity and workload subscription that will be hosted as part of our environment, and execute it. It might take a bit of a few minutes, but eventually the environment will be up and running, pretty much well configured. Everything is closed and encapsulated, and pretty much ready for additional usage and implementation. So this was the demo. Let's go back to our presentation and summarize the content that we just saw. So in this demo, we reviewed two use cases that are ideas for implementation as part of the OpenAI landing zone environment. We want to implement an API management in front of the OpenAI service. Using API management allows us to implement subjects such as rate limits, such as IP whitelisting, such as a policy to control the request and the response. We also gain additional security benefit of encapsulating the OpenAI access key. We do not have to share it across various users. Everything is stored in a centralized location, and then controlled using this gateway allows us to have a secure environment, scalable environment that we can monitor and have better control of. The next use case was setting up an application, a simple web application. It could be more complex as well. This web application is configured to be accessed internally. It accesses the OpenAI through the API management or directly, can work both ways. And the idea here was to see that we can make sure that the application is accessible only from within the virtual network, only internally, and not accessible from the outside. We could harden the environment by providing another layer of defense in front of the app service. We could use an application gateway. We could use an Azure front door that serve as a layer 7 load balancers, including the ability to define them as a WAF, as a web application firewall, and then enable public internet connectivity to our application, but in a lot more secure manner. We took focus on a specific requirements around the network connectivity, network traffic management and connectivity. We saw the usage of two subscriptions, one to enforce all the connectivity requirements of the subscription, the hub and spoke virtual network, making sure that everything is defined as privately accessible. Nothing is accessible from the external internet. We also control the outbound traffic from our environment to the internet using the Azure Firewall service. We use the hub and spoke networks. That way we will be able to control the scalability of the system. It's also better, good for the manageability, having one single point of access, one point that connects to everywhere in our subscription and our environment, making sure that there is a single point of access and control. VNet peering to enable communication between the networks, allowing for better segmentation and control of the network and the traffic. Jambox virtual machine, which is a remote server, can be Linux, can be Windows, where we can connect privately to the environment and control and work with the control plane of the environment itself. And the Azure Firewall, which was in charge of the traffic to make sure that the outgoing traffic will not get to any unwanted places that might happen due to some security breaches in our environment. And the next slide is the summary of the resources that we addressed in this session. Great place to get started working with the cloud adoption framework provided here. We have the landing zone, again, a great place with the documents and summary of the environment on ideas, design area, guidelines, and a lot of documents to get started and use it. Two more articles, great articles that summarize the concept of the OpenAI use case of the landing zone. And finally, the GitHub repo containing the Terraform that will deploy the environment that we just showcased in the demo a few minutes ago. And if you would like to keep in touch with us, just scan this code and we will take it from there. It would be great to further hear from all of you.
Yeah, thank you for joining us.
Thank you very much.